Welcome everybody to our video on variables, data types, and formulas.
Woohoo!
So this video is going to be just a basic overview of these concepts so that when we come across them later, you'll understand what we're getting at when we say int and char and string and the rest of them. So what is a variable?
I don't know. What is a variable?
We'll start there. A variable is a symbolic name that represents a value within a computer program.
Interesting.
So in other words, it's a label applied to a location of memory where we store some value. So how do we declare a variable? Well, each variable has a name or a label applied to that variable. That name can only be certain types of characters, certain types of legal characters, like a capital A through capital Z, lowercase a through lowercase c, 0 through 9, and an underscore. But also, a variable label cannot start with a number. It has to start with a letter. And it cannot contain spaces.
Yes, but it can start with an underscore if you want to.
That's true.
Yes. So here are some examples of some legal variable names, or here's an example of a legal variable name. Variable 123. And below we have two illegal names, which is 123 variable and variable space 123. Now this is pretty consistent across almost every language. You can't start with numbers.
Yep.
So that's generally, even though this is not specific to a language, it's generally good to not start with a variable with numbers. In computer programming or in software engineering, we deal with two types of data types. Now we've sort of brushed on primitive data types, but just to kind of solidify your understanding, primitive data type is like a building block data type. It's something that is supported by default in the programming language. For most languages, it's and that's why they call it primitive. It's the most primitive form of data storage, and that's a number. Anything that can be expressed as a number is a primitive data type. That's why you have things like integers, characters, floating point, other things like even strings are technically numbers. Mm-hmm. In some languages treat strings as native, some don't. We also have composite, which Brian will tell us about.
So a composite data type is something that is composed of multiple primitive data types. These can also contain other composite data types as well. So it's a data type that incorporates other data types, basically. These you'll find in structures and unions and classes, which we'll get into later. There's also the idea of things being signed versus unsigned. So in primitive data type instances where storing a number, a signed data type is going to be both a positive and a negative number. So negative 100 or positive 5,000. An unsigned data type is where it's only positive numbers. So we don't have the negative property. It's just 0 and above.
Yeah, so you actually allocate the same amount of memory in both cases. But if you're doing something like a 16-bit integer where you have 65,000 potential values. Mm-hmm. In a signed 16-bit integer, you go from like negative 32 to positive 32. And unsigned, you go from 0 to 65,000.
So unsigned data types usually are used in circumstances where you have a math formula that's dealing with very large numbers. A lot of times if you're looking for a large prime number, or sometimes in cryptography, you're dealing in a circumstance where it's not going to be a negative, but the number is going to be extremely large.
And sometimes in cryptography, the numbers you're dealing with are so large, you actually have to import other libraries that manage numbers of that size.
True, because they go well beyond unsigned.
Yeah. So here's a chart that has some common primitive data types that are pretty much consistent across most programming languages. The integer data type consumes about 4 bytes. We also have here the unsigned and signed ranges, which I'm not going to talk about because that's like billions and trillions, and I don't feel like talking about that. The short integer, which is a smaller subtype of the integer, it's 2 bytes, which for those of you that are counting, that's 16 bits. We also have characters, which are 1 byte, and most languages don't allow these to be negative, so we're usually dealing in this positive range. Strings are similar to chars, except for its variables. So a string is a sequence of characters. So this can be 1 byte to as many characters as you have in a string. A Boolean is technically an integer. It's a 1 byte integer that stores either a 1 or a 0. 1 would signify true and 0 would signify false. The float type stores typically about 4 bytes, and it's accurate within 7 significant figures. In mathematics, significant figures basically talks about the preciseness of a number. Mm-hmm. So it's 7, usually that means like 7 decimal places. A double is double the size of the float, so that's an 8-byte value, which is usually accurate within 15 significant figures.